So first part is showing you some sample student semester projects. So here, this first part is just about the formatting of the document. Let me make this a little bit bigger so that you can see it. So this is what I meant by a 2-column style document. If you read other people's academic journals, it kind of looks like this kind of style and format in terms of section names, font style, things like that. And the reason why I picked these out and showed these to you is because they have a lot of the pieces that I really liked, right? Which was a good introduction, talking about motivation, about why they wanted to do the project. They did some data pre-processing or data cleaning, okay? We didn't get too much into that so far, but your next assignment, which I will disclose and release this weekend, will have some part of that data cleaning. And so data cleaning, feature engineering, or one-hot encoding. This is a topic we'll talk about later on in this course, but it's a way of incorporating human words into the model, okay? And then further down, some visualizations that the student did, further down here. Some number of analysis of the numbers. And then of course, a conclusion, okay? So if you read the rubric for the semester project, it does outline specific sections that need to be there. I gave like a large set of section names that should be in your project, and you can pick, I think, up to 5. You need a minimum of 5 of those sections, okay? If you don't have at least 5, then I start deducting points, okay? There's another one that I pulled out from a previous project from another student. Person did pretty well in terms of giving a good abstract or introduction, a first sort of understanding of some of the data, of analysis of the data and visualization of the data. Again, 2-column style format, a little bit sloppy on the edging, but nothing that I penalized the student for. Some trends and the fitting, and talked about how some of these topics that we talked about in the class and how it applies into the student's analysis, okay? So I thought it was a pretty solid paper. And also the project does require the data source to be included as a reference, okay? And also if you use any prior work, if you pull this topic from Kaggle, then I expect the original Kaggle work to be cited as a reference. Yes?
Has anyone ever, like I just saw this, has anyone ever published a patent based on project here?
I'm sorry?
Has anyone ever published a patent based on one of these projects?
Not that I know about. Not that I know about. Yeah. If they did, they didn't tell me. Of course, this is their work. Yeah, this is your work. This is not this publication, this article is not belong to me. This belongs to the student. Okay. That's the reason why I do not publish this online, because it doesn't really belong to me. Okay.
Thank you.
All right. All right. So that was just a second sample of a report made from the semester project. And as I also mentioned, was that I was going to just give you a quick intro about another machine learning project that I saw online. It has little bit to do with our class in terms of concepts, okay? But the technique that they use, of course, is not using Python, okay? And for that, I'm going to bring up something called Visor. So it's a way for me to show you what's on my phone. Okay. So my phone actually, I turned off, well, I should turn on airplane mode, just to show you that I'm not pulling data from somewhere outside the internet, okay? So this is an app that I downloaded the source code from the Apple website. And I happened to take a couple of pictures of things that are on my desk. And so here is my mint can. And it's thinking it's a lotion. It thinks it picked and there's some kind of a lotion. Very low probability of accuracy, right? Another one, let me try this white marker. So it thinks it's a lipstick or a ballpoint. So not accurate. It's largely because I think the training data wasn't sufficient, okay? So the more data you pump into the model, the more accuracy you can get on what the image is based, I mean, what the image is, okay? How many of you have seen the Samsung Galaxy AI? Anybody? Okay, so that one actually, it actually does require the internet. And let me see if I can get it up here quickly. No, don't need that one. And these are just, this is not even a project that I built at all. This is something that's just running. So here's my Samsung phone, okay? And it's a picture of my dog. Hang on. Let me pull up, before I show you my phone, I'm gonna have to pull a picture of something that I don't want to show. Okay, hang on a second. So here, so I'm gonna take a picture of this mouse here, right? Oops. Okay, so with Samsung, they have this ability of circling things and then using the internet to figure out what it is, right? But this is using the internet. So their model is actually running on their servers, and their model is much bigger, a lot more sophisticated. So they can tell, and they can even match other objects that are very similar to it, right? It actually did a pretty good job of knowing that it was some kind of a Logitech mouse and so forth, right? So that's the kind of like the power of the classification regression model that we'll be learning. And so just to give you some ideas about, there are a lot of projects out there on the internet that you could possibly look at to give you some inspirations about what you want to do for your semester project. But these, of course, like the Apple one, that's all built in Swift code, not with Python. And that Apple one, it's all running local to the Apple iPhone. It's not connected to the internet. So it's actually pretty impressive considering that they basically built a framework for something like this to run within a Swift UI or iPhone-based kind of programming framework. Yes.
So say if we have a project idea and like say if we have like a goal, if we don't meet the goal, but like if we can explain clearly why we didn't meet the goal, is that acceptable?
Yes, I mean,
Okay.
the rubric, right, doesn't say anything about meeting a goal, right? Meaning, you got to have those 5 sections. You got to explain what you were trying to do. You're trying to, then you have to explain a conclusion. The conclusion can be, I wasn't able to make a model with high accuracy. It could be that, or I didn't have enough sufficient data to have a good model, just like you saw with the image recognizer on the iPhone. So, but you show the path of how you got there, right? So you, as I was looking at this image recognizer project from Apple, I was actually trying to build my own model of putting in sample images. And I was actually putting skin burn. I talked about skin burn before. So I was looking up like 1st degree, 2nd degree, and 3rd degree burns. But finding a lot of that data on the internet is very hard to find. At least a lot of data. I can find maybe about 100 of each degree type, like 100 1st degree, 100 2nd degree, 100 3rd degree burns. And then I was trying to build a model for it to look at a new picture of a skin and determine whether it's what kind of burn and if it's burnt, So, all right. Any questions about this topic before we jump into the lecture? Okay. All right. So we're going to talk about pandas.